All right, the kids are getting restless. We're gonna try factoring. Hopefully I can get it in. All right, so when we're factoring, you're always figuring out if there's a GCF to be factored out first. That's always gonna be your first step. That's always what you're looking for, always what you're asking yourself. All right, when we begin this, we're actually going to begin by factoring out a greatest common factor. So sometimes you could just look at it and see what the GCF is. If you can't, you could list all of your factors of 12. Of each, oops, that's 32. 32, 2 times 16, times 8. Okay, so my GCF here, the biggest number underneath both, is 4. So my GCF is 4. They both have an X. You take the smaller one. When you're factoring out a greatest common factor, that's the number. The GCF is what you write the most. So I wrote it here just to tell myself what it is. I'm going to divide each term by it. And I'm going to write it on the outside of the parentheses. Inside, I'm going to write the quotient. 12 divided by 4 is 3. X to the second divided by x is x, because you're subtracting these exponents. 1 minus 2 is 1. Plus 32 divided by 4 is 8. These x's cancel out, and you've been factored. To figure out if you did it right, you could FOIL, or you could distribute. This next one, another GCF problem. This one's easier, I think. Any numbers that end in 0 or 5 obviously have the GCF of 5 or 10. This one ends in a 5, so the GCF has to be 5. X squared and x, you're going to take the smaller one, which is just your plain old x. Write the GCF the most, so 5x. 5x, you're dividing by it, and then, sorry, you're writing it outside of your parenthesis. 20 divided by 5 is 4. X2 divided by x is x, plus 25 divided by 5. X's cancel. You're factored. I was just warming us up. Now I wrote a bunch of stuff here. We're factoring the difference of squares. Again, we're always looking for a greatest common factor. In your difference of squares, you're going to have 2 terms. The first one must be a perfect square, aka you could take the square root of it. The second term must also be a perfect square, and there must be a minus sign somewhere in the problem. The exponent of the variables must be even. So it should be x squared, x to the 4th, x to the 6th, x to the 8th, x to the 10th, etc., etc. Always check the parenthesis. Oh, and if you have all of these things, I'm sorry, then you set up your factoring problem. One parenthesis gets a plus, the other one gets a minus. It doesn't matter the order. At the very end, you always check your parenthesis with the minus sign to see if you could factor it even more by all of these steps. So the very first one, you have x squared minus 9. Well, this is a variable to an even exponent, and the square root of 9 is 3, and there's a minus sign. So I had all the ingredients that I needed. The difference of 2 squares, 2 squares, and the difference is the subtraction. To figure out what x times itself gives you x to the 2, you take this number, the exponent, and divide it by 2. So 2 divided by 2 is x, and the square root of 9 is 3. And they're the numbers that you're going to enter into your parentheses. One gets a plus sign, the other gets a minus. And you're just dropping them in like that. You can FOIL them to see if it works out, and it will. Then you're checking this parenthesis with the minus sign in to see if they're the difference of 2 squares again. X is not a perfect square because it does not have an even exponent, so I'm done. This is factored out. This one, x to the 4th minus 81. Perfect square because it's an even exponent. the square root of 81 is 9, and we have the difference. So this is the difference of two perfect squares. No greatest common factor, because there's no number out in front of x squared, or x to the fourth. So, the square root of x to the fourth, you take 4 divided by 2, which is 2, so there's x to the second. The square root of 81 is 9. So you set up your two sets of parentheses, one with a plus, one with a minus, or vice versa. I always put my minus second in case I have to refactor this one. You drop them in. X squared is 9, x squared minus 9. Okay? Then you check your parenthesis with the minus sign and see if it's the difference of two perfect squares again. And this looks very familiar because we literally just did it. So this is a perfect square, 9 is a perfect square, and we have a minus sign. So I could factor this again. When you have to do this, you always keep the first parenthesis. It's x squared plus 9, I'm just copying it. But for this one, since I could factor it again, I'm going to have to put two more parentheses. One with a plus, one with a minus. And since we did this one already, we know that this is x. We know that this is 3. So 3. We know that this is factored all the way because we just did it. So basically, this factored is very similar to this one, except for we had the addition of the x squared plus 9. But if we know that x squared plus 9 stays the same because of the plus sign, and if we know that this could be factored further, we must do it. So x squared minus 9 is equivalent to the quantity x plus 3 times the quantity x minus 3. So I had to simplify it. Okay, that's the answer there. Over here we have 3x to the second minus 12. Straight giveaway is that neither of these are perfect squares. So I know that I have a greatest common factor. Again, we're always looking for a GCF. The GCF between 3 and 12 is 3. So you divide both of them by 3. 3 divided by 3, they cancel. You're left with x squared minus 12 divided by 3 is 4. Okay, now you look at the parenthesis with the minus sign. You leave your 3 there. This is a perfect square because it's an even exponent. This is a perfect square because I could take the square root and there's a minus sign. So I need a plus sign and a minus sign. X squared, 2 divided by 2 is 1, so it's x. Square root of 4 is 2. You just drop them in. Go to the parenthesis with the minus sign again. X is not a perfect square, so this is the answer. The GCF, if there is a GCF, it always comes down. Probably forgot to tell you that because I'm distracted. Hey girls, I'm trying to do something. The greatest common factor always stays out in front. Okay? Last two. This one, x to the fourth perfect square, square root of 625 is 25, so I have x2, and I have 25. So you set them up, plus with a minus. Look to the one, the parenthesis with the minus sign. Is this a perfect square? It's even, so it is. The square root of 25 is 5, so that's a perfect square, and I have a minus sign. So I could factor this again. This, if you have to continue to factor it, always just comes down. You don't have to do anything to it, but you just have to recopy. And here, x squared is x. Square root of 25 is 5. And you just drop that in there. Look to the minus sign. X is not a perfect square because it's not to an even exponent, so I'm done. The last problem like this has a GCF because they're not perfect squares. The GCF here is 2. Dividing this by 2, dividing this by 2. So this is x to the 4th power minus 16. Look to the minus sign. This is a perfect square because it's even exponent. This is a perfect square because the square root of 16 is 4. The minus sign. So 4 divided by 2 is 2. Square root of 16 is 4. Bring your GCF down. Plus, minus, x squared and 4. X squared minus 4. Not completely finished. I have to look at the minus sign. Is x squared a perfect square? Well, it is. Even exponent. Could you take the square root of 4? You can. It's 2. So I have to do it again. So 2 divided by 2 is x. Square root of 4 is 2. Setting up your answer. Bring down your